So if you download the lecture note outline, you'll be able to fill in your outline as I fill in mine. This whole section is going to be about solutions, and solutions are important because most chemical reactions occur in some sort of solution. So what is a solution? A solution is going to be a homogeneous mixture. Now, homogeneous means same. So our solutions are not going to have any layers to them. When you look at them, they will look uniform. What's a mixture? Well, a mixture is two or more substances, and they're physically combined. Are physically mixed, but not chemically. Now, I mentioned that a solution might be salt water. It's a fairly common solution, salt water, sugar water. In this combination, salt would be the solute. It's the minor component. So this would be the salt. The solvent with a V is the major component. And this would be the water. Now, when I gave my example, I gave it as salt water, and that is a very common solution. But must the solvent be a liquid? And it does not have to be. The answer to this question is no. You can have air that's mixed in air. In fact, the air you're breathing right now is mostly nitrogen with some oxygen mixed in. So the nitrogen is the solvent and the O2 is the solute, along with CO2 and argon and some other things. You can have gas in a liquid. For example, you can have CO2 in your soda. Here, the CO2 is the lesser amount, and it would be the solute. You can have liquids dissolved in liquid. Ethanol is frequently dissolved in water. You can have vinegar dissolved in water. You can have solids dissolved in liquids. So we had the salt and the sugar, or salt in water. We can also dissolve sugar in water. Lots and lots of chemicals are can be dissolved in water. You can also, somewhat surprisingly, have solids in solids. So zinc is dissolved in copper, and that makes brass. We also put carbon in steel or iron, in iron to make steel. If you buy tools, you might have noticed that a lot of times they will say that they're chromium, that it has chromium steel in it, and that has chromium and carbon in it in iron to make the chromium steel. It makes it harder. Okay, so I mentioned solid and liquid, and in both cases I gave water as the example. Water is a super good solvent, and the reason it's such a good solvent is that it has kind of a negative part and then it has positive parts. And so it's able, we call this characteristic being polar. We've talked about polar molecules before. It's polar because its electrons are distributed unevenly. And we can have hydrogen bonds form between the water molecules, as in this picture. This negative oxygen is being attracted to the positive hydrogen. This, y'all can't see this. Okay. This oxygen is being attracted to this hydrogen, and this hydrogen is being attracted to this oxygen. So that's making these hydrogen bonds. So oxygen, water can solubilize ions, like here's a sodium ion, and it's positively charged. We can get oxygen facing it all the way around. And the hydrogens, the positive hydrogens, are away. And we can solubilize this positive ion. If we have a chloride ion, the water just faces the other direction. We get water molecules all the way around. Except this time the hydrogens are a little bit positive, and they're going to be attracted to this negative ion. There's my hydrogens. I always think of these as Mickey Mouse ears. Okay, so the hydrogens face away if the ion is positive, and they face toward if the ion is negative. So they're able to solubilize both negative and positive ions. So water is a very polar solvent, and hexane here is very nonpolar. So we've got a large separation of charge, and we've got partial charges here and partial charges here, and no charges here. Remember, unlike charges attract. So if we have octane, we would expect it to not be soluble in water, but to be soluble here. Ethanol, well, we've got all this end of it has no charges, but we have a dipole here. Oops. There you go. The oxygen is going to be partially negative, and the hydrogen will be partially positive. We'll get hydrogen bonding with this construction, and it will be soluble in water, but not in the hexane. We've got these charges, and there's nothing that attracts here for those charges. If we have iron sulfate and iron supplement, we make iron ions, which are going to be soluble in water, just like the sodium chloride was, and sulfate ions, which are also soluble, but not soluble in the hexane.